So, let's see. One of those. So, that's that. Here's our definition. A function capital F is called an antiderivative or indefinite integral for the function little f if capital F is differentiable and capital F prime equals f of x. A given function has many antiderivatives. Think about this. What if f of x is 3x squared minus 5? Wouldn't this capital F be the antiderivative? If I took the derivative of capital F, what do I get?
6x.
Would that be 3x squared minus 5?
Yep.
What if I took this f? What's the derivative of it? It's little f. What if I took the derivative of this capital F? So do you see they're all the same except for that constant that's added there? So in general, this is what we could say. All right? Okay? Only differs in the constant c, which we call the constant of integration. So here's how we'll define that. We're going to say, let f and g be antiderivatives for f. Then there exists a constant c such that g of x, one antiderivative, is another one plus some constant c. They only differ by the constant. Okay? Here is our notation for this. Okay? This little symbol will be called the integral sign. All right?
What?
This little symbol looks like a thin S. Right? That's called the symbol for integration, integral sign. Okay? If I want to take the integral of f of x dx, that is capital F, your antiderivative, plus some constant c. Okay? So in other words, if I go backwards and find some function that I can take the derivative of to get little f, that is my function, plus some constant c. It doesn't matter what the constant is, because the derivative of a constant is 0, isn't it? So I could say it's that, remember that first example, what was it? X cubed plus 5x, I could say plus 9 minus 6 plus 50,000. Doesn't matter what the constant is, just plus some constant. They would all be antiderivatives of little f. Okay? For instance, would you agree with this? If I want to find the antiderivative of 2x, when it says dx, right now let's think of that as this differential dx, think of that as with respect to x. Find the antiderivative with respect to x. Okay? The antiderivative of 2x is x squared. Couldn't it be x squared plus 5, x squared plus 9, x squared minus 15? If I took the derivative, I get 2x, don't I? That's it. Okay? How about this one? The antiderivative, the integral of 4x cubed minus 2. Would you agree that that's the antiderivative? What if I take the derivative of my answer? What do I get?
Is there a reason it's in parentheses?
Yes, this is my function with respect to x.
Do we always have to tag on the dx?
What if this was like 4y cubed minus 2, you would have dy there. Or if it was something like 4m cubed minus m dm, they're just saying with respect to that variable. Okay? We call that the differential with respect to x, and it's going to have a different meaning in two sections. But right now, just think of that as with respect to the variable x. Okay? All right. But you agree with this, right? You see, if I want to take the antiderivative of this, I would get that, wouldn't I? Well, we need some rules to tell us how to get that, right? You don't want me to just say guess at it till you get it right, right? Well, I think you're going to remember how we found derivatives, right? What was our rule to find the derivative of this? 4x to the 4 minus 1, right? Well, to go backwards, I'm going to have to add 1 to the exponent and divide by that new exponent. That's going to do it. So I think that's...
anti-power rule.
So here it is. Here are my rules. See if you like this. The power rule to go backwards, the integral of x to the n with respect to x to the n plus 1 over n plus 1. So rather than drop the exponent by 1 when we took a derivative. Now I'm going to add 1 and divide by that new power.
Why is it n plus 1? Or not at the top, but at the bottom. Why is it n plus 1?
Look at that example. Look at this example. Here's a good one. Would you agree that if I want the antiderivative of x cubed, it would be x to the 4th over 4? What's the derivative of this? 4x cubed over 4. The 4's would cancel. You get that back. So in other words, so that 4 would cancel, I have to divide by the new exponent. What would be the derivative of this? 4x to the 3rd divided by 4. The 4's would cancel, and you would get x cubed. So if you don't divide by that new power, see, 3 plus 1 is 4, divided by that new power, then it works if I take the derivative. Look at this one. X to the negative 2. Well, if I add 1 to that, what do I get? X to the negative 1 divided by negative 1 plus c. And I simplified that to this. What would I get if I took the derivative to check it? I better get this. Do I? Negative 1 in front would mean x to the negative 2, wouldn't it? If I took the derivative of that answer. So we're trying to go backwards. That's why it gets a little confusing, right? We're so used to taking derivatives and dropping the power by 1 and bringing that exponent in front. Now we have to go backwards. We add 1 and divide by the new exponent rather than multiply 1. Okay? It just takes getting used to it. And that's what I was telling somebody. Becky came to the office and I said, people get confused here at the end. They'll learn to find the antiderivatives, but on the final, when I say find the derivative, they get confused because you're so used to going this way. Now when you go backwards, it starts to get tricky, right? So when it puts it all together on the final, it's sort of like, oh, you're pulling your hair out. But we're going to get around that, aren't we? How about this one? If I add 1 to 1/2, what's my new power? 3/2 divide by 3/2. So there's my answer. When you divide by a fraction, it's the same as multiplying by the reciprocal. Plus c, plus any constant. Always say that plus c or you're going to have a point counted off. All right? That was what called? That was the power rule, right? What if it's just a constant? What if I said, what's the antiderivative of 5 dx? Wouldn't it be 5x plus c? Because the derivative of 5x is 5, isn't it? So if it's a constant, you just tack on an x. Okay? Here's the one that gets people the most. The power rule works for every power except negative 1, because what does x to the negative 1 mean? 1 over x. Well, we said the derivative of natural log was 1 over x. So if you want to go backwards, the antiderivative of 1 over x is what? Natural log of x. So anytime you see the antiderivative of 1 over x, think I'm going backwards to log, because the derivative of that is this, wasn't it? Sometimes in the book, they won't say x greater than 0. They'll put absolute value around that x. So don't be afraid of that if you see it. Okay? Here are the rules for exponentials. Remember how we said the derivative of e to the x is e to the x? Same thing if you go backwards. The antiderivative of e to the x is e to the x. If this is a more complicated exponent, we have to do that in the next section. That's going to be reversing chain rule, which is going to be a little more complicated. All right? And that's what this will be. This is 6-1 up to here. Remember how we would take the derivative of a to the x? Wasn't it a to the x ln x? From the board, we said there weren't any in the book. To reverse it, you would divide by ln of that base. Okay? A to the x ln a. To reverse it, a to the x divided by ln a. So, there's our rules for 6-1. Why don't we do some practice now? Let's see if you feel like that's going to be good. Let's just do some of the even ones. Look at number 12. Feels like, see where I had that down to 72. 12 says, what's the antiderivative of 2x to the 5th dx? power rule said, do what to my power?
Add 1.
Over what?
1. Or 5.
The new
Six.
power, plus C. We'll reduce that. If you don't feel comfortable with that answer, what could you do to check it?
Right.
Take the derivative to see if you get what you started with. What's the derivative? 6x to the 5th over 3, which is what? 2x to the 5th. Have I convinced you that this is not bad? It's just going backwards from what we're used to?
No.
Add 1, divide by that new power. I could bring that 2 outside here if I wanted to, that coefficient. But it's fine if you just leave it right there. But that's my answer. How about 14? You try that one. Same rule. You see, it's a t and it's dt. See that? With respect to t.
And so we just put equals, we don't put capital F
Right.
prime or any of that sign.
They're saying, what's the integral of this little f? And this
Uh-huh.
will be capital F.
Okay.
What would that power be?
It's -6.
Over what? Reduce it for me. What's my final answer?
1 over.
Like that? Would that be okay? Does it work if I bring the -6 in front to take the derivative? That would be a 3t to the -7, and I like it. Plus any constant. That's not bad, is it? You see the pattern? Yeah.
What is the hard at?
Yeah. But we're gonna deal with it.
Okay, I'm sorry. I don't understand why you split it into 2 pieces right there.
Here,
Yeah.
I just wanted to reduce that fraction. What is 3 over -6?
-1/2, but don't you still have to divide the 6 by, or the t by the 6?
Only if it were a plus or a minus between them. Then you would split it into 2 fractions. But remember, if it's a product over that, if you cancel it, it's canceled. Remember that?
I mean, is that what we're going to do for product rule?
In other words, if I had 2x over 4, wouldn't you say that that's 1/2 x? But if I had 2 plus x over 4, it would be 1/2 plus x over 4, wouldn't it? That's what you're asking.
Yeah, but then why didn't we do that to the other one?
It was multiplied.
No, but why didn't we do that?
Oh, we could
This
write it,
one.
I could write it as
1/3
x to the 6 plus c. That's the same.
So it doesn't matter which way we read it?
I just thought it would look nicer if you could have said t to the -6 over 2 with the negative out front. That's fine. I just thought that looked a little better if you wrote the fraction in front. I see what you're saying.
Okay. I just got confused why we did it on one and not
These
the
are
other.
equivalent. These are equivalent.
So do you want us to leave it in a fraction, or do you want us to simplify it?
Whichever way is best for you. If you want to call this negative t to the -6 over 2, that's equivalent to that. That's the same answer. Same. Whichever you feel comfortable.
It took me a little bit to realize what you were going with it.
You know what I thought they might do? I thought they might say -1 over 2t to the 6 and make that negative power positive, but they started with the negative power, so they're going to leave a negative power. So, it's just in the way you simplify it. Could you do 18? There we go.
Are we going to do double antiderivatives?
Say that again.
Are we going to do double antiderivatives?
No, that's beyond. If we had applied 2, we would. Yes. 1 will be enough this semester.
Can you see how that whole area?
What will my new power be? If I add 1, it will be positive 1/3, right? So 3x to the 1/3 over that new power. Now tell me what that is if I simplify.
Is it not x to the 1/3 plus 6?
Yes. Here you go. Because when I divide by a third, I multiply by 3 over 1, and that makes it 9. If you take the derivative, are you satisfied? 1/3 in front makes it a 3. Subtract 1, I get negative 2/3. The derivative of whatever constant that is would be 0. That would be it. How should I write number 20 to make it easy to work with the power rule? 20 gives me the integral of 1 over 3x to the 5th.
Could you do 3x to the negative?
Yes. But the 3 would stay down, wouldn't it?
Yes.
So I would say 1/3 x to the negative 5 dx, right? That sounds good. Bring that power up to the numerator as negative 5. Now, tell me what it would be. 1/3.
X to the negative 4 over negative 4?
Yes. Add 1 over that negative 4 plus c. Now, what's a good way to write this? This looks ugly.
X to the negative 4 over 12.
Right? Could you write it like this? Is that good? Either way. Bring out that negative 12 in the denominator as a fraction, negative 1/12. And that would be equivalent. I could write it negative 1 over 12x to the positive 4. That would be okay, but I don't think they want me to go that far. Maybe they would, since they gave it like this. If they gave it like this, maybe they would want it. Negative 1 over 12x to the 4th plus c. You never know how they'll give the answer in the back of the book. They sometimes do it on a whim as to what they feel is most simplified. How about 22? How would you rewrite that one? 3 over square root of t dt. T to the what? I like it. If I bring that, that's t to the 1/2 down there. If I bring it up, it would be 3t to the negative half. Now what's the new power? If I add 1/2 over what? What would the book say? They might even go so far as to say 6 square root of t plus c. Either one is fine. Just be aware they're equivalent. Okay? Just to put everything together, how about 30? Do it term by term. They say the antiderivative of 2 plus x plus 2x squared plus e to the x dx. Okay. What's this? 2x, right? Remember that ax rule? If it's integral of a, it would just be ax. That's good. Or 2x to the first over 1 is great. What would this one be? How about this one? Plus what? Best I could do. No like terms, no like powers. Do you see what I'm saying, though, that once we start doing this, if I go back and say find the derivative, you're going to maybe get confused? But always remember to check your answer. Derivative of this, yes. Yes. 6x squared over 3. Derivative of that, it works, doesn't it? Don't forget your plus c. They keep going just like that. Don't do 36, but in 36, how would you rewrite the first term as a fractional exponent?
Would it be
X to the 2/3 power, number 36. Yes. In 38, before you do it, you would have to split that into two fractions and simplify them before you take the antiderivative of each term. In 40, let's don't do it, but 40 you would distribute first and then find it term by term. That makes sense, doesn't it? If you distributed the u to the -2. I think we should go right to 44. That one looks good. Antiderivative. How should I write square root of x? Plus 3 over x minus 2e to the x dx. Okay, help me do this term by term. Remember, once I take the antiderivative, this is not here anymore, right? What is this one going to be? Over. This is the tricky one we haven't seen yet. What did we say the antiderivative of 1 over x was? ln. So I would think of that as 3 times 1 over x. And so what's the antiderivative going to be? 3 ln x. Because if I take the derivative, what is it? 3 times 1 over x. And there it is. That's the toughest one to see sometimes, getting used to going backwards to ln. And this one's not bad. What's that? And what do I take on? Plus c. I could write this one how? That would be fine. Okay? All right. Now, what would you say to 52? 52 says find f of x by solving the initial value problem. They say f prime of x is 3x squared minus 6x. And they tell me that f of 2 equals 4. What's the ordered pair? F of 2 equals 4. 2, 4. Tell me what f would be if I find the antiderivative to get f. 3x cubed over 3. Well, what's that? 3x to the third over 3. The 3's would cancel. How about this one? 6x squared over 2, which is 3x squared. Plus what? But what did they tell me? They gave me a point that it goes through, right? So if y is 4, x is what? 2. So 2 cubed minus 3, 2 squared, plus c. I can find c. 4 equals 8. What's this number? Minus 12 plus c. 4 equals 8. 4 equals negative 4 plus c. You're right. If I add 4 to both sides, c equals 8. So tell me what f of x is. X cubed minus 3x squared what? That's 8. And that is what they want. I actually could find the constant that time. Because they gave me that ordered pair that it goes through. So once I found f, with my plus c, just plug in your x and y and solve for c. That's called an initial value problem. Try that with 56. Let me give you a minute to try that yourself. What will go here? 2x squared over 2, the 2's would cancel, do you agree? Then what will I say? Plus c, yeah. 2 equals e to the 0 minus 0 squared plus c, is that right? What's this? 1 minus 0 plus c. So what's c? Good. So what's my f of x that I would write down as my answer? E to the x minus x squared. These aren't that bad, are they? It's the same question but different wording for 60. In 60 they say find the function f given that the slope of the tangent line is f prime of x and the graph of f passes through the given point. Its initial value but just stated a different way. They give you f prime, they give you a point that it passes through, and now you find c. So let's do 60. Says f prime of t is t squared minus 2t plus 3, and the graph of f passes through 1, 2. So what's f? T what? Over good. What would be next? 2t squared over 2. What happens to the 2's? So just minus t squared plus what? 3t, and then plus what? Starting to feel comfortable with these? All right. So then I have to say what would go here for my initial value? The y is 2, the x value, the t is 1, so 1 cubed over 3, 1 squared, 3 plus c, 1/3 plus 2 plus c. What is 2 1/3? Well, actually, would it be easier if I just said subtract 2 from both sides? 0 equals 1/3 plus c. Well, what's c then? Negative 1/3. That would be the easy way to do it, right? If you get scared of fractions. Okay. So my f of t would be t cubed over 3 minus t squared plus 3t what? Minus 1/3. And that would do it. Okay. Look at 70. $70 gives me the cost of manufacturing these guitars is the marginal cost, the C prime of x, is 0.002x plus 100. They say that the fixed costs are $4,000 a month. Well, doesn't that mean if they sell 0 guitars, it still costs $4,000? There's your initial value, isn't it? The fixed cost would be $4,000. Okay. What's C? X over what? 2 plus what? Plus C. Okay. So that means C of x is 0.001 x squared plus 100x plus C. Now, if x is 0, C will equal 4,000. So could I just go ahead and put the 4,000 right there? Because it said if x is 0, that's what your constant would be. So C of x would just be 001x squared plus 100x plus 4,000. Okay. In that case, the plus C is your fixed cost. So your fixed cost would be 4,000. I'm not going to make you do 72. It's very similar. They give you n prime of t, and then you would find n of t by taking the antiderivative. But do you see the hint in part A? It says n of 0 equals 0. So in other words, C would be 0 for that one, wouldn't it? So there's no constant to add. So your plus CC would be 0 for number 72. Okay. The ones I want you to try from this set, see how these go at home. I hope they'll go well. 406, 9 through 47 odd, 51, 55, 67, 69. That's all that I'm expecting from that section. Just like the ones we did. Okay. Now, here's where it gets fun. What if I said that we had a function and we had to find the antiderivative, but we had to reverse the chain rule? That's what we have to do next. And this takes a little more thinking and planning, but it's just as easy. I hope you'll find it. So that's what I want to show you now. That's our next part of the notes. Finding antiderivatives by substitution or reversing the chain rule. Okay? This is what the format that we're going to look for in order to reverse it. Remember how we would have a function, an inner function and an outer function for chain rule? We would take derivative of outer times derivative of inner. Remember that? Well, in order to go backwards, you know what I have to have? I have to have the whole derivative of the inside function out here with the dx before I can go backwards. So if you look in here and you find something like 3x squared plus 7, you would have to have a 6x out here next to the dx, or you can't reverse it. Does that make sense? when you get your answer, if you take the derivative by chain rule, you would get this whole string. Derivative of outer times derivative of inner. That's the whole idea behind it. The book is real heavy on you figuring out, calling your inner function u and making a substitution. I don't like showing it that way. I like to just list it out and say, what's your inner, what's your outer? Is it there? Let's go backwards. And I think you're going to find that easier, because sometimes if you make substitutions, you start to really lose track of what's going on. Okay?
So just know inner times outer times derivative of both.
Yes. Let's look at this one. Do you see, here is a big function, isn't it? Do you see the inner function is that exponent? What's the derivative of that exponent? It's with the dx, isn't it? So when I go backwards to find the antiderivative, if this is here completely correct, I just don't look at that and I go backwards. Well, what's the antiderivative of that e to the u? E to the u plus c. Do you see how that just disappears as long as it's there? Because if I took the derivative of this, what would it be? Wouldn't it be itself times 2x? So we're just saying, make sure the derivative of the inner is here, then just disregard it and find the anti. Look at this one. This is great. What's the derivative of the inner here? Is it with the dx? Well, what would be the antiderivative of that from what we just finished? What would you do? To the what? Fifth over what? There it is. To the fifth power over 5, which is 1/5, right? Plus c. Do you see this anywhere? No. That has to be there, though, because when I take the derivative, it would be times the derivative of the inner, wouldn't it? So you just have to get this set up to where your du is there. They call this du. If this is u, that would be du. Is your du complete? That's what I'll ask you. Is your du complete? Is the derivative of the inner here with the dx? If not, you have to adjust it. But then you just go backwards. That's the whole section. But it takes some practice to get used to. All right? So see what they say? Let u prime x dx be du, then f of u du is f of u plus c. Would be the antiderivative. Okay. But I'm not going to make you make that substitution. I'm just going to say, is the du complete? And I want us to practice them. I think that's it. Let's practice. Yes.
And this is 6.2.
This is 6.2. This is on page 418. Okay. Number 2 says the antiderivative of 4x, 2x squared plus 1 to the 7th dx. Let's rearrange that. Let's put the big function first, the outer, and then put derivative of inner with the dx. So would you agree I could rewrite this 2x squared plus 1 to the 7th with what out here? Times 4x dx. I just put this over here. Now you tell me, what's the derivative of the inner? Is it all here with the dx? Well, I'm ready. I'm going to disregard that, and what is the antiderivative? To the what? Over. You're done. How's that? If this is not complete, you can't go that step. If the derivative of inner is here, just disregard it and use your power rule. And you've got your answer. Isn't that great? Okay. Okay. Let's try another. This
So
one is
so, but what, are we going to do it this way, or are we going to do the substitution? Or
I wouldn't. I would do it this
do
way.
it this way?
Yes. See what they would want you to say. They would want you to call this u to the 7th du, and then go back and substitute your u back in. That to me is too complicated. As long as you know your outer and your derivative of inner, go for it. Right?
And there's not a difference between putting your 8 in the denominator than putting 1 over 8 to the side, correct?
1/8. 2x squared plus 1 to the 8th is exactly the
Okay,
same.
all right.
Very good. Very good. How about number 8? I want to see if you can get this one. What's the big outer function? That's my outer, right? T cubed plus 2 to the 3 halves. What's the derivative of the inner? Is it there? 3t squared dt, if I rearrange it, it's all there, isn't it? No adjustment needed, just disregard that. What is your antiderivative? To the what power? If I add 1 to that, 5 halves over 5 halves plus c, how would the book write that? 2 fifths. There you go. Do you see if you took the derivative of your answer, the 5 halves and the 2 fifths would cancel, times this to the 3 halves, times 3t squared? You would get that, wouldn't you, if you took the derivative of your answer? But sometimes it's hard for people to think, well, where did this go to? Well, that just needs to be there so I can go backwards. This is no longer there if I add 1 and divide by the new exponent. It's just the power rule. What do you think? The hardest one for you to recognize is going to be number 6. Maybe. How should I rewrite number 6 the way we've done these others? Yes. 3t squared plus 2 over x cubed plus 2x to the second dx. I would write that with a negative power. I would bring it up. So would you say that I'll put x cubed plus 2x to the what? Negative 2. And then what will I tack out here? Is this complete? What's the derivative of n? It's all there, isn't it, with the dt?
Is it all x's?
Oh,
It's
I'm sorry.
Because
Yeah, I was like, wait.
It's all, it's all,
it's all
X's.
x.
I'm sorry. It's all x.
I just got a little confused for a second.
Wow.
You're not the only one.
I just wrote it just like you did.
I did too. I'm like, yep.
Why did I even think that?
Yep.
Because we've been switching between x and
I guess we did 8 with t's, and then I had t on the brain. Did you say this was complete? So now what is the
It
anti?
is for trouble.
X cubed plus 2x to the what?
-1.
Over what? Now how would the book write that? They probably wouldn't leave it like that.
1 over x squared plus 2x.
Mhm. This would drop down, but remember this negative is just would be a coefficient, wouldn't it? So would you say negative 1 over x cubed plus 2x to the first plus c? I don't need parentheses there, do I? Because there's no power except for 1. So I guess just to make it look better, I would say x cubed plus 2x with no parentheses there. Okay? You know what the hardest one I see next is 30. 30. 30 is a little tricky. Actually, can we do another one before 30? 18 makes a good point. Says x squared minus 1 over x cubed minus 3x plus 1 dx. Alright.
Did you put the bottom to the negative first power to get rid of the fraction?
The last one we brought up as -2, didn't we? But since it's just to the -1 power, what if I rewrote it like this? Would you recognize what major type it was? What if I just scooted this over with the dx? What did we say 1 over u would be? Natural log. But what's the derivative of this inner? Is it complete? What's missing? 3x squared minus 3. I need a 3 outside that. But if I put a 3 in here, what do I have to put outside? To balance it. If you need to put something in to make it complete, you have to balance it outside, so you've done 1. 3 over 3. So if I put a 3 here to make it 3x squared minus 3, I have to put a 1/3 outside to balance it. That's the first time we've seen it where it wasn't complete. I had to insert that 3 and balance it outside, so it's now done. Okay? Now that I've put the 1/3 outside, it'll stay outside. But what is the antiderivative if I disregard this now? Plus what? Did that blow your mind, or is that good? Do you see what what's the derivative of this? 1 over that times the derivative of this. And if I did that and divided by 3, it would cancel, and I would get this back, wouldn't I? Wow. We just did a lot, didn't we? This was not complete until we put a 3 here. If I put a 3 inside, I've got to put a 1/3 outside, so I haven't changed the value of the polynomial. It balanced it because 3 would cancel, leaving nothing. So if it's not complete, you can adjust it with a constant, not a variable, with a constant, but you have to multiply by the reciprocal outside. That's the big step in this section that's tricky. Okay? Want to try another one like that? I like 24. It's another one before 30, right? 24 is good. X squared e to the, is it x cubed minus 1? Dx. How would we rewrite that? The main function is this, isn't it? And what will I shift? X squared over with the dx. What's the derivative of that inner this time? What? 3x squared? So what do I need here? I need a 3 and what outside? Now that that's complete, what can I say? 1/3 stays there, but what? Itself plus c. If I took the derivative of this, it would be this itself times 3x squared. The 3's would cancel, and I would get this back, wouldn't I? You really have to plan for these, don't you? You've got to think ahead to go backwards. But if it's all there, you just go for it with the rules we did in the last section. So look what we did. We did power. We did ln in the last problem. This one was e to the x, wasn't it? E to the u. We've reversed all the types, haven't we? They get a little trickier as you go on down. I think we should do 30 just to show you that it could get a little hairy. 30 is e to the negative 1 over x over x squared dx. What's your main function there? That's my main function. What if I just rearrange it then and say e to the negative 1 over x times 1 over x squared dx? I just need to know what the derivative of that inner is, and is it all there? What's the derivative of negative x to the negative 1, which is what that is? What's that? It's all there. I don't have to adjust it, do I? The derivative of this is that. So what is the antiderivative if I just disregard it?
That was a lot easier than you made it sound at first.
But sometimes noticing what is your major function and what's your inner derivative is tough. When you get down to ones like 38, could you pick it out?
What if one of those?
What's major and what's derivative of inner?
The ln x squared
Yes.
major,
Yes.
and 1 over x squared.
So how should I rewrite it to make it look better so I can use my rule?
Ln x
ln x to the what?
negative square 2. Sorry. Times 1 over x.
Ah, I love it. What's the derivative of inner? It's all there. So what's my anti? Is that right? How would the book write that? With a negative out front? Bring that out front. Let's see.
Would it matter if you left it in the denominator?
If you just left it x, ln x to the negative 1 with the negative out front, that would probably be just fine.
No, I meant like if you had 1 over negative ln x plus c.
You would never, like, if you had this fraction, would you ever write it on a test as that?
Probably not.
So you wouldn't want to leave the negative on the denominator problem. That's a sort of a bad form. But that's a good question. It's equivalent. It's equivalent, but you just don't
It
leave
just
it like
looks
that.
bad.
My math lab wouldn't like that, but we don't have mine. So it's up to me to not like it. And I would be lenient on that probably. That's what you would see in the back of the book if it were homework question. All right. Let's see. Okay. 43, did you say?
42.
42.
What
Oh, let's do
main
it.
function do you want in?
Let's do it. Looks like we might have to do 2 separate pieces.
That one looks so crazy.
42 says x e to the negative x squared. I might split that into 2. I'm going to put the dx here and then do a second integral of e to the x over e to the x plus 3 dx. You could split it like that into 2 antiderivatives. Would you agree that this one I could rewrite as e to the negative x squared x dx? But what's missing? It's not complete. That derivative is negative 2x, isn't it? So what do I need to put here? A negative 2, a negative half outside. Go ahead and do this one. If I rewrote that one, 1 over e to the x plus 3 e to the x dx. Let's just scoot that over. What's the derivative of the image? It's complete. No adjustment needed. All right? So if this is now complete, what's the antiderivative? Plus, go ahead and do that one. What's this type? 1 over u? Ah, natural log. Natural log of e to the x plus 3. Now plus c. You can just add one constant for both pieces. And that would be fine.
So you can separate them like that.
Say that again?
You can separate them.
Yes. Remember how we were doing these where we would have the integral of x squared plus e to the x dx? You could write that as integral of x squared plus the integral of e to the x. Put the dx on both of them. Remember how that was written maybe like that in the last section? You could split that into two antiderivatives, do them separately. So that was much easier to think of separately. Okay? What if we skip down to 52? This is another initial value problem, but using this format. 52 says f prime of x is 3x squared over 2 square root of x cubed minus 1, and the initial value point for the function is 1, 1. Passes through 1, 1. F does. Okay? Now, if I want to find f, I need the antiderivative. What's the major function then?
X cubed minus 1 raised to the negative 1.
Ah, x cubed minus 1 to the negative half is what that is. What if I shift over the 3x squared with the dx there? This 2 is not, what is the derivative of that? Isn't it just this? Well, that 1/2, I'm going to go ahead and just bring out as a constant out front since it's not needed. Yeah, I don't need that 1/2, so I'm going to bring it outside as a constant multiple and just say I'm complete there, and then I'll multiply by 1/2 at the end. So that'll be 1/2. If this is complete,
You just grab it, and then just do x cubed minus 1 to the negative 1. No, to the positive 1.
over,
Over 1/2 plus.
oh, well look what happens. The 1/2s will cancel out, and I don't even have to invert, do I? Plus c. Now what do I do? If that was f of x, then I can use my 1, 1, can't I? 1 equals 1 cubed minus 1 to the 1/2 plus c. Well, that's easy. What's 1 minus 1?
I think that is your exponent still negative. Like you had negative 1/2 up there, and then you went down below it. It wasn't negative anymore.
But I add 1, don't I? This exponent plus 1 over the mu exponent to take the antiderivative,
Oh.
you add 1.
Yeah.
That's good. That's good. So it became positive 1/2. So 0 plus c is 1, so what's c? C is 1, so what's f of x? F of x is x cubed minus 1 to the 1/2. Or I could write square root, couldn't I? Want me to do that? That means the square root of x cubed minus 1 plus 1. That would do it. You still on the boat or jumped off the boat yet? You with me on those?
Hang on.
You hanging on to the side? If we can do one more, I think we're set for these two sections, and then you'll have some good practice. 57, I think, is the last one we need to do. Okay. 57 says the registrar at Kellogg University estimates student enrollment in continuing ed will grow at the rate of n prime of t, which is 2,000. 1 plus 0.2t to the negative 3 halves. Okay. If the current student enrollment is 1,000, t years from now, this is good. This is for 2 years from now. Current would mean at year t equals 0, the enrollment's 1,000. So that's my initial value. 0, 1,000. Find an expression giving you enrollment 2 years from now, and then plug in a 5. Well, how about n of t? This one, it might be easiest to bring the 2,000 outside. Yeah, this would be to the first. This would be the only thing. It would be like over to the 3 halves. If I wrote that, just this would go down. So this is up. This is up times 1 over 1 plus 0.22 to the 3 halves. That's good. That's good. But yeah, this is the only expression that would go down. This would stay in the numerator. So I'm going to bring the 2,000 out. That's if you add something in. Remember how we took that 1/2 out in the last one? That 2 that we didn't need, it was already a 1/2. We just brought the 1/2 out. If it's already there, just bring it outside. Sort of like if you said this, if you said, if you had the integral of 2x, couldn't you say it's 2 times the integral of x, and it would be the same thing? I could bring that 2 outside.
Because it was the expression over 2 square root of x cubed.
And this is part of the function, and I didn't add anything where I would need the reciprocal. I just need to bring that 2,000 out as 2,000.
So you couldn't solve that by putting 2,000 in front of dt?
Oh, I do need a dt once I write the integral sign. So look at this, though. I thought this might be easier because it's not going to be complete, is it? I need 1 plus 0.2t to the negative 3 halves dt. But what's the derivative of n? I need a 0.2, so I'm going to go ahead and divide by 0.2. 1 over 0.2. I could have tried to take part of that 2,000 and wrangle, but that would be too hard, wouldn't it? I think I'm just going to say I needed a 0.2, I'll divide by 0.2. All right? So that's going to be, let's see, n of t will be, what is 2,000? Whoa.
10,000.
Let's see here. I don't need to do that. Let's see. Can I get back to just my, yeah. There we go. You said that is 10,000. Oops. 10,000. Since that was complete, what's the antiderivative? Negative 1/2 plus c. Okay. What about if I put in, if t is 0, n of t is 1,000?
But you don't divide by -1/2 for the 1 plus 0.22.
Oh, yeah. Thank you. I would divide by the new exponent. Thank you. Yes. So that's going to be actually negative 20,000. 1 plus 0.2t to the negative 1/2 plus c. Okay. Now if I put in t is 0 and n of t is 1,000, let's find c. 1,000 equals negative 20,000. 1 to the negative 1/2 is just 1, isn't it? If that's a 0, So would you agree that C is 21,000? Okay. So let me write that over here. N of T is negative 20,000. I'm going to write this as over square root of 1 plus 0.2t plus 21,000. That would be my function. And I won't make you suffer through plugging in 5. They said, what, when t is 5, what would n of t be? You could all do that with your calculator, but it's basically I want you to find that function, and that's it. The ones I want you to try from this set are page 418, 1 through 41 odd, 51, 53, and 55. And that's all. And that's, I will have your 9th take-home quiz next time. After that, what we do next time, the last type of problem, there will be one last take-home quiz, which I'll give you Monday. Okay? I think a week from Wednesday will be our 4th short test, just over chapter 6. Okay? Just over integration.
So next, not this Wednesday, next Wednesday,
Right.
short test.
So basically what we're going to do a week from today is we'll review for test 4 and we'll review for final. And then we'll have that test the last meeting day of class. Final on Monday.
Do you know what time it is?
2:30 to 4:30.
I have
I'll
one
be up here a
from-
little earlier than that. I'll be up here at 2:15 maybe.
I have one
If you
from
want.
12:10 to 10,
Oh.
so then I get to come right.
If things get too logged up for you, I do have other options, like you could take it maybe Tuesday if you had 3 finals the same day, but you just let me know.